Hello, welcome to Saraswati Online Classes, where we do give best and quality content to everyone. Is this live? Can I see? Yes, like it is live, and I'll 1 second. Yeah, let's we start the topic for the more topics. Today we will learn triangle law of addition, parallelogram of addition, polygon law of addition. In the graphical, these all topics will be mentored to you in the name of the topic graphical method of vector addition. Yesterday we learned so many things, right? Um, shall we once revise those things? Yesterday we learned scalar quantities, differences between those. What are scalar quantities? 1 second. There's such a scalar quantities are those which are having only magnitude. Vectors quantity magnitude. 1 second. Magnitude plus direction. All quantities which have direction and magnitude cannot be vector quantities because they should follow certain rule called vector law of addition, which we'll be learning today. As I said in the 1 second. As I said in the today's goal, it is on what I said. Hi, Rapid Bamshi. Yeah, it is this live coming. Nothing is visible for me. Yeah, as I said, vector law of addition. We'll learn today graphical method of vector addition. This is actually the rule which I am going to. I was saying yesterday the differences. This is a basic difference, and we learned. 1 second. We learned 1 second. We learned why do we need vectors, that is in order to get the physical quantities direction and magnitude, in which direction the force or something the physical quantities acting in order to know that we need vector. We studied that, and we studied the differences between the vectors, that is it has numerical value as I said and direction of based vector law of addition, which we are learning today. And we learned the note that all vectors have directions but all quantities does not or called not sorry, all vectors are direction but all quantities are not vectors, because since they follow certain rule called vector law of addition. And representation of vector head, tail, etc., and graph not directions I said, and we did some problems on those. And important points related to the vector: on rotating 2 pi r, vector does not change. It means that if you in a circle, if you go from starting point and come back to starting point, it means no displacement. So vector is also zero. A vector can shift parallel to itself, that is called shifting of vectors, or parallel it can shift from anywhere, one side of the thing to another parallel side of it. And the angle between the vector is small, of the two is small angles joined by tangent, so that theta will be lying between 180 degree. We did some problems, and I explained you some of the things like 120 degree, 300 degree, how to find those. And now today we'll start with types of vectors. Okay, we'll start with types of vectors. One second. Yeah. As types of vectors, there are around 8 vectors and two no important vectors. Namely, I say equal vectors. What are equal vectors? The vectors, if two or more vectors are said to be equal if they have same magnitude and same direction. Say we have vector A. Okay, this is the vector B. This both which have same magnitude and same direction is called as equal vectors. And negative vectors. Negative vector. The vectors whose magnitude are equal but directions are opposite are called as negative vectors. How do we know this? Take a vector A, take a vector B of same magnitude, that is same length, and name it as vector B. This is called negative vector, and negative vector is represented as minus B. It is if you take this as positive, this will surely become negative, right? That is the thing which we follow. And now we'll learn parallel and anti-parallel vectors. The parallel vectors are those vectors which have same directions are called parallel vectors. They are parallel to each other and have same directions are called parallel vectors. And what I can say, the angle between them is zero. Parallel vectors. Let's take A. Wait, I'll change the color. Take this. Yeah. Take A. This is a vector A, as I said. To parallel of this, the, they are same in direction, but magnitude may differ. Okay, the magnitude sometimes may differ. Then also it is called same parallel vectors. A B are called parallel vectors. Okay, anti-parallel vectors. Anti-parallel vectors are those vectors which are opposite in directions are called anti-parallel vectors. Parallel means like this, two lines having the 90 degree, and the theta between them should be 0 by solving some equation. I will tell you the what is that equation in later. Okay, now we'll first learn anti-parallel vectors. This is the vector A, this is vector B. Both are parallel, and the what I can say, that is the angle between the theta between them is 90 and theta is 0, as I said. Okay, sorry, in anti-parallel vectors, sorry, I made a mistake, one second. In anti-parallel vectors, in anti-parallel vectors, take a vector like this, and if we take a parallel vector, one second. Yeah, now what I was explaining, anti-parallel vectors, right? The vectors which are opposite in direction and parallel to each other. See, the distance between them is like this, whereas so your theta will become 180 degree, since they have anti-parallel inductors, and if you take in clockwise it will become 180 degree. By applying some rule, I probably tell you in this class what is that rule, by vector law of addition. You can understand there. Now, sorry, now we'll learn first concurrent vectors. The vectors which intersect at a point are called concurrent vectors. What does this mean? Let's take a vector f, and let's take a vector f1. In case f1 and f2 intersect at some point like this, this is f1, this is f2, then this point, these type of vectors which intersect at some point is called concurrent vectors. Let me repeat till now what I said. Types of vectors: equal vectors, the vectors which are same in magnitude and direction are called as equal vectors. Negative vector which are opposite in direction but same magnitude are called as negative vector. Anti-parallel and parallel vectors: in parallel vector the theta is 0, anti-parallel theta is 180 degree, and the in anti in the sorry in parallel vectors, the the two vectors are in parallel in direction, magnitude may differ. Anti-parallel vectors are those vectors which are parallel to each other and the theta is 180 degree, and opposite in direction. Anti-parallel, opposite in direction mainly. And we were learning concurrent vectors first. And concurrent vectors are those vectors which two vectors intersect at some point are called as concurrent vectors. The point of at which they intersect are called as concurrent vectors. Note that vectors which are having initial point are called in co-initial vectors. What I said, note in concurrent vectors that the vectors which are having common initial point are called co-initial vectors. Concurrent which intersect, like what I said in concurrent, which intersect like this. Yeah, let's take example like this. If understand better like this, with intersect like this, or you can say two vectors have gone like this, they have gone like this, they have gone. This point of intersection is called concurrent vectors. Whereas in co-initial co-initial vectors co-initial vectors, the vectors which are having same common point of origin. Let's say this is the origin O, this is vector A, B, C. Okay, these are the three vectors which are originating from a common point called O. Then they are called co-initial vectors. And now we'll learn collinear and coplanar. Vectors acting in same line are called as collinear vectors. What they are called collinear? If say two vector, sorry, one second. Let's say this is a vector and another vector is also acting in the same line. Then this type of vectors is called collinear vectors, and and theta is here also 0. Okay, and coplanar vectors. The vectors which lie in same plane are called as coplanar vectors. Take xy axis. This is x axis. Sorry. This is x axis. This is y axis. This is minus x. In this, if vectors lie in this range, then these type of vectors which lie in this plane are called coplanar vectors. You can take it if you want to take a 3D plane, draw x z axis also. Okay, the 3D plane actually looks like this. This is xy axis, another perpendicular to each other comes z axis. This is 3D. This is 3D graphical representation in mathematics, that graph. Okay, now we'll learn unit vector and zero or null vector. And null vector. Unit and zero or null vector. Unit vector. Unit vectors are those vectors which are having magnitude 1. What are unit vectors? Unit vectors are those which are having magnitude equals to 1. But I'll change colors so that you can identify. Magnitude equal to 1. The purpose of unit vector is used to indicate the direction. Since magnitude becomes 1, there is no point in the magnitude and it only indicates the direction. Unit vector. Then there is a thing where you represent the unit vector like this, a cap. If you put a cap on this, like one second, if you put a cap on this, this is called cap, and we read it as a cap or hat. We read it as a cap or a hat. Okay. In some books they have given a hat. In some books they have given a hat. A cap, a hat. Now we usually, the formula for a cap is a vector of a and magnitude of a. Then that becomes equal to magnitude 1 and the direction is left, so it is called the unit vector. Please do like, share and subscribe. I can see 2 people watching and nobody are liking it, only one who on like. And now we will talk about the zero vector. Okay, or null vector. A vector whose magnitude is 0 is called null vector. The direction of null vector cannot be specified. It is denoted by 0 and the arrow, above arrow. Okay, what does that mean? A vector whose magnitude is 0 is called null vector. Means if you do not have any direction and which cannot be specified, uh, so it is called, if your mother asks to go from here like this something and all, you cannot do anything. So at that time, in unspecified direction, you cannot make out direction, since then the vector is called zero vector or null vector. Usually it is usually represented as 0 to the on the top of 0 we write an arrow. It is called zero vector. A free vector, this is an additional information I am giving. Free vector, a vector which remains unchanged when it is displaced parallel to itself, is called free vector or non-localized vector. What is free vector? A vector which remains unchanged even though if you displace when it's displaced parallel to itself, is called free vector or non-localized vector. Localized vector which cannot be displaced. What is the meaning of displaced? I'll tell you, wait. The word displaced means it has taken over place, position or role of move. You have moved, right? In free vector, you do not. If you move, also the vector remain unchanged. It is called free vector or non-localized vector. Localized vectors are those vectors which are having. It cannot be displaced. It can. If it is displaced, also. Sorry, it cannot be displaced. In free vector, it cannot. If it is displaced, when it remains unchanged, even though when it is displaced. Okay. Now we'll move to the graph methods of vector addition. This is the rule which I was talking to you in some while. Okay. One second. As I was saying, methods of vector addition. This is a rule which I was talking in the difference between scalar and vector. Now we are going to study the vector law of addition. In which way we represent? There are two methods: graphical method or geometrical method, and second one is analytic method. First, we will see graphical method. What do we see? Graphical method. One second. What is this one? Something sound, bike sound is also coming here. In the graphical method, there are three laws: triangle law, parallelogram law, polygon law. We'll study one by one. Okay. First, let's go to the triangle law. Before we go to the triangle law, I need to say something to you. What is that? I'll show you. One second. Yeah. First, what is addition? Here I should change to white. Right? Yeah. What is addition of vector? It means if we add a vector and plus vector, it gives rise to resultant vector. If we add two vectors, the resultant is also a vector. It does not change to scalar. That is a rule. Keep in mind, if they are to your question, what does happen if you add two vectors? The resultant will be what? That is also a vector. See, if you take vector A plus vector B is equals to vector C, right? This is the important thing you need to follow. And the subtraction, wait one second. Subtraction of vector is also a kind of addition. I'll show you how you can think how the subtraction become addition. I'll tell you.